Okay, good afternoon, everyone. Okay, uh, in last session, we have discussed some of the topics related with doubly linked list, right? So, you can say which operations we have already discussed in the last session. You can write it over here in the chat. Those who know the answer, they can write. Yes, we have discussed doubly linked list, some cases related with the doubly linked list. So the topic name which we have already discussed in the last session, you have to just write the names over here. How many cases we have discussed in the last session? One, insertion operation. Good. Other, only one student is present in that session. 41 students are present in the last session, right? So everyone needs to give me the answer. Okay, so we have discussed insertion operation in doubly linked list. Okay. Now we have a deletion operation in doubly linked list. Now, first of all, uh, we have a node is deleted at the beginning, node is deleted at the end, node is deleted after a given node, and node is deleted before a given node. We have four cases. First case, node is deleted at the beginning of your available linked list. This is you can say linear doubly, not the circular. Okay. The first thing, what we are trying to do, we are setting our ptr variable equals to start. Now start equals to start of next. So now my start is going to pointing at the next node. Now what is the connection you need to, or which pointer you need to replace with some value? So you can say now your new start a previous portion you need to make it as a null, and you have to free your ptr. Now node is deleted at the end. Now from the last you can say from first node to the last node, you have to traverse the entire linked list to delete the last node. Okay. Now what you are trying to do, So I have two variables with me, one that is PTR, second that is pre-PTR. Now you have to repeat step number 5 till your PTR is not reached at the last position. Okay. Now before moving to the next node, whatever the value of my PTR, I'm going to store into the pre-PTR. Okay, so now pre-PTR equals to PTR. That means, first of all, I'm taking the value of previous PTR into the pre-PTR, and then I am jumping towards the next node. Okay, so my pre-PTR is one before my PTR. Okay, or you can say my PTR is next of my pre-PTR. Now set your pre-PTR of next is equals to null. Why? Because now I'm going to set my pre-PTR at the last second node, and last node is known as the PTR. So now if I'm deleting that PTR, my pre-PTR is going to known as the last node. So now my pre-PTR of next, I'm making it as a null and pre-PTR. Now next, that is node is deleted after a given node. Okay, so after a given node, that means I need to give some value to your to delete the next node. Okay, so same like this, I have a PTR and pre-PTR with me. Both are starting with the start variable. Now pre-PTR of data part is not equal to null till you have to shift your PTR as well as the pre-PTR. Now, what is this? This is, you can say your temp equals to PTR of next. Why I need to use this temp? Because if I am inserting something, so the PTR of, if I'm deleting something, so that node address I need to assign into some way, in some node address. Okay, so that's why I'm taking it into the temporary variable. Now my pre-PTR of next is equals to PTR of next. So whatever the PTR of next, I'm storing it into the pre-PTR of next. Okay. Why? Because I want to free my PTR. Okay. And PTR of previous, I'm going to store into the temporary of previous node. And I'm going to free my PTR variable. Okay. Now node is deleted before a given node. Okay. Now, what you have to do, set your PTR equals to start and pre-PTR equals to PTR. So now PTR of data is not equal to num. You have to shift your PTR. Okay, so I'm reaching at this node PTR, and before that node, I need to delete my pre-PTR, not the PTR. Okay, so now pre-PTR of previous, I'm going to store into the temporary variable. Then temporary variable of next part is equals to pre-PTR of next. Why? Because next time I need to give that address to my next node. That's why. Okay. And here the pre-PTR of previous, I need to store it into the PTR of previous, and I'm going to free my pre-PTR. Okay. Understood? Yes? Clear? Okay. Good. Now this is my circular doubly linked list. One question I have asked you in the last session. Okay, that is, what is the difference between singly circular linked list and doubly circular linked list? Okay, anyone? Okay, perfect. That is in a singular singly linked list, we cannot go backwards. But here in a circular linked list, we have a link with, you can say, the next starting node as well as the last second node also. So that if we want to move the backwards, we can move it. Or if we want to move to the first node, or you can say to the starting node, we can. Okay, so the difference between a doubly linked list and a circular doubly and a circular doubly linked list is same as that exists between a singly linked list and a circular singly. Now, the circular doubly linked list does not contain null in the previous field of first, which is this, as well as the next field of last, this one. Okay, correct. Now, rather the next field of the last node stores the address of the first node of the list, that is start. And similarly, the previous field of the first node, stores the address of last node. Okay, and here I can store the start address. So this both the links we need to keep. Now, we have a first case, insert a new node at the beginning of the node. Yes, so what we have to do over here? So in this case, let me explain one more time. Yes, so if I want to insert one new node over here, then I need to change this link as well as this link, and we have to give this both the links. Okay, clear. Now, if I want to insert one more new node over here, so what we have to do? So first of all, we need to create one node over here, right? I need to give the link from this node to the starting node, this one link, okay, as well as this last node link with the previous one, as well as I need to break this link and I have to give this link like this. Okay, done. So we have to do this many things. But if I want to insert a node after this 2, let's say for example, I want to insert a 8 number node over here. Whatever the node, 15. Say for example, I want to store 15. Okay, after this 2. So is there any change in my start node or in the last node data? No, I just need to change this 2 links. I need to give something like this as well as this, and I'm breaking this 2 links. Okay, so this is similar like only doubly linked list. Okay, this is similar like this, but if we want to insert one new node over here before your you can say starting node, as well as the insert at the last node, so in that 2 cases only you need to change the links of last node as well as the first node of circular doubly linked list. Okay, so we are not discussing this thing that insert after and insert before in circular doubly linked list, because this is same like a linear doubly linked list. Okay, now, so what we are trying to do, so till this I think you don't have an issue. Now, if I have a new node which is going to be inserted over here, right, this one. Now what you have to do, this new node of data is equals to 12. So I'm filling this part. Yes, so I'm filling this part with the, you can say, 10. Now PTR equals to start. Yes, I am starting with the PTR. So my PTR is at this location. Now PTR of next is not equal to start. Now if you want to find the last node, how can you find? Here we don't have any null value with us in a circular linked list, but yes, we have one option that is known as whatever the node next part contains the address like same like a start node, or whatever the nodes last or you can say next part contain the start node address that is known as my last node. Okay, so I am doing the same thing, that PTR of next is not equal to my start. I need to shift my PTR to the next, right? So I'm starting from this node. Last node, last, next node contain the starting address. No, this one, no. Here, no. So jump towards the next. Here, no. Then I am reaching at this location. Now my P is going to pointing at this last node. Forget about this P. Okay, now what is the situation? So you need to do something like PTR of next is equals to new node. So this is my PTR of next. Here you need to give the address of this node. So I guess this node address is X, suppose. So this node last part can contain the address of new node. So now this node is going to pointing at this location. So I'm building this link. Now new node of previous is equals to PTR. Now I'm standing over here, right? This is my new node. So what is the previous portion going to fill, or what is the value we need to fill it in the previous part of my new node? So you can say last node address, but I can't say last node address. So that's why I have one PTR variable with me. I have already mentioned this address with PTR name. So now whatever the address of this PTR, I'm going to store it over here. So PTR address, you can say PTR. Okay, assume whatever the address of last node, this one. Okay, now new node of next is equals to start. So now I have filled my data part. I have already filled my previous part. Now it's time to fill the this one part. Okay, so now I have already built this link also. This one. Okay, now I need to give the link between this new node and this start node, right? So what I'm trying to do, I'm putting the address of start node over here into the next of my new node. So I have built this link also. Now this starting node pointing at this location, but now I need to build this link between this and new node, right? Yes, so the start node of previous, you have to fill it with the new node. Yes, so start of previous assigned with the new node. Okay, and now my start pointer going to store the address of new node. So now my start is going to pointing at this location. Okay, clear? Yes. Okay, so now you can write your enrollment number for the attendance purpose. Write down your enrollment number. If you are facing any network issue, you can inform me right now. Afterwards, I'll not allow you. Mahir, can you write your number over here? Yes, Mahir.
Hello, ma'am.
Yes.
I can't write.
Say your name, please.
Selvi Kamani.
Okay, yes, Shelby. Your number is
116010
191070
two
7006.
six
Okay, 26.
7026.
Shelby. Okay, done. Okay. Yes, Mahi. Are you able to write your number? Yes, your number is available over here. 601 8. Okay. Other than this, any student can't write number? Okay, no. Okay, done. Okay, so Hiren, why are you late? Network error. You have to inform me, na? Mihir, क्यों लेट लिख रहे हो नंबर? बोलो.
હા મેમ હું ડિસ્કનેક્ટ થઈને પાછો આવ્યો કેમ કે મેસેજ નહોતો થતો.
Okay. Okay. Insert at last. In circular doubly. Okay. Okay, so what we are trying to do that first let me draw this. Okay, now imagine that this one is my new node. Yes, is there anyone who wants to say something? We'll discuss it later. First, let me complete this. Assume that in between this two node, we have so many nodes, okay? Because if I will try to do everything, it will take time. Okay, so that's why this is something like this. Let me keep the address over here. This is 200. Address of this node is 10. Now this one is my first node, and this is my last node. Okay, assume something like this. And I want to insert one new node in between this. Sorry, not in between, but I want to insert a new node at the end of this is my new node. Okay, and the connection with this node is available with me. Like this. This is you can see your connection. Correct. As to this 205 is my new node, and I want to insert this node at the end of this available list. Okay. Now I'll ask one by one, and you have to give me the answer. Okay. Now, first of all, state number 1. What we have to do? Okay. Not I'll ask one by one. Those who know the answer, they can write over here. First thing, what we have to do, according to your, you can say your understanding. First thing, what we have to do. Okay. I'm giving you the time, something like state number 3, avail is equals to avail of next. Now this is your state number 3, you can see. Okay, now next step you have to give me. What should I need to write over here? अवेल का कनेक्शन मैंने दे दिया, मुझे एक न्यू नोड मिल गया. अब सबसे पहली चीज आपको क्या करनी, ये न्यू नोड का एड्रेस है 205. दिस इज माय न्यू नोड. This is my new node. 200 to 205. What it means? 200 to 205. I can't understand. Okay, आप ऐसा समझ लो कि इन दोनों के बीच में बहुत सारे नोड्स अवेलेबल हैं. Right. Assume that this is 203. Okay, and here also we have a 203 node with us. Okay, there is no any major issue over here, but our main thing you need to do is we just need to concern with this new node. Okay, you need to give me the state number 4. This is my new node. First of all, you have to fill this data part of new node. You can see that how many of you are understand this algorithm perfectly. I need to fill the new node of data part. What is the answer? New node of data is equals to VAL. Is it so? Correct. Good. Now what is the fifth one? State number 5. Fill the next part or previous part of the new node. ऐसा करना है जो आंसर ना दे उसकी एब्सेंट. You have to give me the answer, the previous node 210. Yes, so here you can write. But how can you write directly with the pre portion? How can you write it? You have to shift na. New node of previous equals to PTR of next. How can I say this is my PTR? Do I traverse the entire linked list? Did I do that? Or did you find out the PTR over here? Yes, very good. So you can do this, that new node of next part, you can fill it with the start. Why? Because I have start variable and which can store this 200. So I can write 200 over here. Right. So I am doing this kind of thing. Right. Okay. Now you have to traverse the entire linked list. Start traversing the entire linked list. Yes. Astha, Deep, Dairya, Hiren, Karthik, Krishna, Kumar Pal, Nirali, Part, Pujariya, so many students over here in the lecture. You have to give me the replay. What is the step number 6 over here? You need to start traversing the entire list. What is the first step? Shreya, Janvi, Shelby, Nancy, મારો ક્વેશ્ચન તો સમજાય છે ને હું શું પૂછું છું? Am I clear with the question? Okay. Okay, good. You need to give me the state number 6. Now, I want to fill this portion. I want to fill the portion of this. Okay, so what we have to do, we need to start traversing our list till last node. Okay, so what we have to do, that first of all we need to find which one is my last node. So after getting Umang, correct, yes Umang, just wait. Okay, now after getting the last node, I need to fill this previous portion of my new node. Okay, but how can I find out the last node of my available linked list? So you have to start traversing from the first node. So first of all, what I have to write, I'm taking one temporary variable which is known as the PTR, then till you can't reach, you can't get the last node, you need to shift your PTR to current node, to the last, sorry, to the next. Okay, from that current node to the next node, you have to shift it. Okay, so how we can start? So you can say that, first of all, how can you reach at the last, how can you find the last node? So whatever the node is containing the start address in the next portion, that node will become the last node. Yes, here you can see this, that in this node, how can I find the last? So jiske paas last next node, next portion mein जिसके भी पास null value है वो मेरा last node है, right? But in the circular list, how can I find out the last node? So whatever the node, next part containing the start node address, that is known as the last node. So you have to, while your ptr of next is not equal to your start variable, you have to shift your ptr equals to ptr of next. So many times we have discussed that how can you traverse the linked list. Okay, now I have reached at this position. This is my ptr. Okay, now okay, if I want to fill this portion, what should I need to write? So you can say new node of previous can be filled with the value of ptr. What is the value of ptr? So value of ptr is equals to 210. This is the address of my ptr. So this is ptr. Assume that this I am giving the name to the location of 210 as a ptr. So now I can say that here you can write it that after reaching at the last position, right, I can say that ptr of next is equals to new node. So now this will become 205 and I'm building this link. Yes, correct. Okay, now I need to build the link with the previous node. So what should I need to write over here? Give me the step number 9. I want to fill this previous of new node. Previous of new node. New node of previous equals to ptr of next. No. Yes, Krish, correct. So you can write, okay, first of all, the ptr is giving me 210. I need to fill this 210. So ये सोचो किसके पास 210 है, तो आप बोल सकते हो ptr के पास, right? So मुझे किसका पार्ट फिल करना है? Then you can say that new node of PREV में मुझे फिल करना है 210, but I can't get the address, but I have the name of that 210. What is the name of 210 location? That is PTR. Correct? Fine. This thing. Okay. So it can give me 210. Okay. Now I have to give this link. So what should I need to write? इसका नेम क्या है? फर्स्ट नोड का नेम क्या है पहले वो सोचो. 200 मुझे 200 जो भी है उसको मैंने क्या नाम नेम दिया है? सो यू कैन से स्टार्ट. Yes, because your start variable can pointing to the 200 location. Yes, so new node of next equals to start, already done. Now you have to change this location, this one. This you need to give this previous link, this one link. You have to change this location. स्टार्ट का प्रीवियस मुझे किसी वैल्यू के साथ रिप्लेस करना है. स्टार्ट का प्रीवियस. जाकी, जैनित, यतीश, वैभव. You can also give me the answer. I want to fill start of previous is equals to new node. Correct. Start of previous, you have to fill it with the new node. So what is the value of new node? So you can say new node value equals to 205. Okay, good. Okay, so this is the algorithm. Okay, then now new node is deleted at the beginning. Okay, now you need to delete the node. Okay, so what we are trying to do, that if you want to delete the start node, so your next of your start node should be known as the start. Okay, and that node previous portion you have to fill it with the last node, right? So something like this. This is my last node. Okay, so you have to change the last node next part this one, right? Now this one will become your start node. Okay, I want to delete this. Okay, so this previous new node previous part you have to change, and the next of your last node you have to change. Okay, yes. So do I need to traverse the entire list? If I want to delete the first node, is there any requirement to traverse the linked list? Why? So how can I change the last node next part value? You can unmute yourself and give me the answer if you have the answer. Just you have to change the values in the next node and last node. But how can I reach at the last node, Krish? I don't know now which one is the last node. Otherwise I can directly move to that location and change, making some changes. Yes, in that way we have to travel. Okay, good. So what we are trying to do, so we are taking one ptr variable which is starting from the start. I'm taking that start of next into the temp. Start of next into the temp. So this is my temp variable. Okay. Now I'm moving from a first node to the last node. PTR of next is not equals to start. So I'm reaching at this location. So here my PTR is standing. Okay. Now set your PTR of next equals to temp. PTR of next equals to temp, because now I want to delete this now. Previously here the start node address is there, but now I need to give this temporary variable, temporary node address. So this is the address I'm writing over here. So this link is building. Now the temporary of previous, you have to set it with the PTR, this one. Now this link is going to build between these two nodes. Now I can free my start, this one, and whatever the temp variable is known as the start. Okay, same here in the deleting node. So if you want to delete the last node, how many things you need to change? First of all, you need to change the start variables previous portion, as well as the last second node next part. Okay, so I am moving with two variables. First, that is ptr, second, that is pre ptr. Okay, so if I want to free my ptr, so my pre ptr will become the last node. Yes, so pre ptr of next, I am changing the address of with the start node. Okay, and start node previous address, I am changing it with the pre ptr. Okay. Okay. Yes, first node and second last node. Yes, correct. So you just need to build only two links. Okay, and if you want to delete the node from, you can say in between two nodes, that I want to delete the fourth number node. Okay, and I have 10 value in my list. Okay, so there is no any major changes in your head node as well as the last node, right? So there is no any changes in this. So circular linked list, delete the node after given value is same like your linear doubly linked list. Okay, correct. Okay, so yes, one small thing, that what are the applications of your linked list? You can just give me this question answer in the next session. What are the applications of my linked list? Okay, applications of doubly or maybe circular linked list. Okay. Okay, now we have chapter number 3, that is non-linear data structure. Okay, now what is linear data structure? So you can say the elements are adjacent to each other, or exactly you can say like two neighbors elements which is connected with the each other. Okay, so you can say array, linked list, stack, and queue. Okay, now before we are moving towards the next chapter, one small question is for you, that is application of linked list. Second question, if I want to design a stack, if I want to design a stack using singly linked list, can I represent it? Can I implement it? Yes. The simple question, if I want to design a stack using linked list representation, can I represent my stack? मुझे एक stack को represent करना है linked list के through. Can I Yes, I can do it. What are the operations I need to perform in that? We have, yes, it will be easy, no changing notes. Yes. But how can we do it? How many operations we need to perform? Or what are the operations? It is seen like insert from beginning, correct? One is insert from beginning and deletion from, yes, correct, near to the answer. Uma. Pop from the last. No. Sunil, if you are doing this, then it is known as queue. Stack has having only one end. Yes, now you are correct, Sunil. So insertion from beginning and deletion from beginning. So only one end. So whatever the data you have inserted first, it is always going to be added at the last. Okay, you can say if you want to add 5, so 5 is now my last node. If you want to insert 6, 6 is inserted at the beginning. If you want to delete, you can only delete 6. So insert at the first, delete at the first. Okay, if you want to make a queue, linear queue, not the circular. So which type of operations you are required? From which end you need to insert and from which end you need to delete? Insert from the end. Yes, insert from the last, delete from the first. Yes, Milan. This is the representation of queue. First in, last out. But if I want to make my, if I want to design my queue using linked list, can I do this? Yes, you can. Right. This is the thing. Insert from last, delete from first. Okay, good. Very good. So from next lecture and onwards, we are going to start the tree concept, which is non-linear data structure. And we are just going to define the tree, what is branching, branch, root, children, and the levels, hierarchy of trees, types of trees, how can we insert, how can we represent, all those stuff we'll discuss from the next lecture and onwards. Okay, so if you have any doubt in this chapter, just refer it, we'll discuss it in the next lecture. Okay, okay, so you may leave the session. Thank you, class.